Good morning, students. In this video, I am going to explain the seventh experiment, that is determining the solar cell characteristics. We'll see what is the solar cell and what are the main parameters required to understand the performance of solar cell, and also we'll see the detailed experiment here. The main aim of the experiment is to obtain the IV characteristics of and to determine the fill factor of the given solar cell. We need to understand the voltage and current flow in the solar cell and also draw the IV characteristics, how it is changing graph, and also fill factor. Fill factor is also a main parameter for the to understand the function of the solar cell. Apparatus required: the solar cell, variable load, digital multimeter, and micrometer, etc. These are all the main apparatus of the solar cell. The main circuit diagram we can observe here. We need to take a solar cell. We are having in our lab the silicon solar cell, small one, and in which the radiation will fall. For these radiations, artificially we are using a 60 watts bulb, and this is connected to the voltmeter, and it is also connected to the ammeter to measure the current and voltage readings, and it is connected to a variable load or resistor to understand the how the voltage and current varies with these changes in the load. So we'll see the main formula here. We need to understand the incident power. Pn is equal to wattage of the bulb upon 4 pi r square into surface area of the solar cell. The fill factor is equal to Im into Vm upon Isc into Voc. Here we need to understand what is solar cell and what is the function of solar cell before using this solar cell kit. Solar cell is a device which will use the phenomena of photovoltaic effect. Photovoltaic effect is nothing but by incidenting the photons on certain materials, it will take out the electrons and the current flow is possible without any external source. Using the sunlight, these devices of some of the materials can produce the electrical energy. This is said to be the photovoltaic effect. Here the photovoltaic effect is used here to produce the electricity. So to understand the behavior of solar cell, we need to understand the first the functioning of solar cell using the PN junction. Solar cell is a PN junction diode. Here we will use the P-type and N-type semiconductors will be joined together. When the sunlight will falls on the junction area, then what will happen? So the photons will create the electrons. Photons will generate the electrons. The photon energy is transferred to the electrons. That electrons will gain the energy and will move to the contact area. At the contact area, that will be captured by the at the contact materials, and it will flow in the battery. So here the solar cell is having the different types of material. P-type and the N-type material is joined, combined together and connected to the battery. This battery is observes the electric voltage can be captured by this voltmeter. Here we are having the main four parameters we need to understand: open circuit voltage, short circuit current, and also fill factor, efficiency. These are all the four parameters are using to understand the performance of the solar cell. A short circuit voltage, short circuit current or open circuit voltage is nothing but when the two ends of solar cell are not connected to the any device, then the voltage, maximum voltage flowing in the solar cell or circuit is said to be the open circuit voltage that can be measured by without connecting any device. And short circuit current is nothing but the how much the current is, maximum current flowing in the circuit, that can also be measured using the ammeter. And a fill factor. Fill factor is having a particular formula. This formula is Im into Vm upon Isc into Voc. Im is the maximum current, Vm is the maximum voltage, Isc is the short circuit current, Voc is the open circuit voltage. The fill factor is nothing but Im into Vm upon Isc into Voc. R is the distance between the bulb and solar cell. Here we can calculate these all parameters from the graph and circuit diagram. Im is the current corresponding to the maximum power point. Vm is the voltage corresponding to the maximum power point. Isc is the short circuit current and Voc is the open circuit voltage. From here we can calculate the series resistance. Rs is equal to 1 upon slope, and parallel resistance Rp is equal to that can be calculated from the graph. So here we will see the procedure. Connect the circuit as shown in the circuit diagram. We need to connect the circuit. It's a simple circuit connecting just voltmeter and ammeter as shown in the circuit. Keep maximum load and measure the corresponding voltage and current. Keep the maximum load variable resistance or maximum load and change the load for a particular time and measure the voltage and the current. Start reducing the load. So we need to keep maximum load, resistance is maximum, and after that reduce the load slowly and take the corresponding voltage and the current readings. Take enough readings for the graph. So we need to take the readings of voltage and current using the voltmeter and ammeter. This is only the task we need to do here. Only we need to keep first that resistance high, and after that we need to increase the voltage and current. We need to reduce the that load given, and after that we need to calculate the voltage and current. Start reducing the load and measure the corresponding voltage and current. Take enough readings for graph. Minimize the load and measure the corresponding voltage and current. Plot a graph of current versus voltage. Find maximum current, maximum voltage, and short circuit current and open circuit voltage from the graph. Use the given formula to estimate the incident power. Calculate the fill factor efficiency for the given solar cell. From the graph, note the readings, that is changes in the voltage current, and also voltage and changes in the current as shown in the figure. Plot the graphs of I versus delta V and V versus delta. Calculate the series and parallel resistances using the given formula. So here we need to, and this is the tabular column we are having voltage and current. How the voltage and current changes we can note down in this tabular column successively, and after that we can draw this graph. Voltage is taken on here voltage is taken on the x-axis and current is taken on the y-axis, and draw the graph. How you can understand how the voltage and current variations are there in the solar cell by changing the load, by changing the resistance. So first we are giving the maximum resistance, after that we are changing the, after that we are changing the resistance slowly and understanding the changes in the voltage and current. Here the voltage and current variations are shown in the graph. Here voltage is taken on the x-axis and current is taken on the y-axis. From that we draw the graph. Here this is the voltage current variations. Here the maximum open circuit voltage is on the x-axis, and maximum current is showing, that is the short circuit current is on y-axis. Here from that you can calculate any 2 points on this and take any 2 points on the graph, and that is Im is the on x-axis and Vm is on x-axis and Im is on y-axis. From the graph you can understand VOC, ISC, Im and Vm, and from that you can calculate this, you can understand this tabular column I delta V, V and delta I. From this you can draw the graph I and delta V, V and delta I, and you can take the slopes of I versus delta V and V versus delta I, and from that you can do the input power, that is voltage of bulb upon 4 pi r square into surface area of the solar cell. These can be calculated easily from the device. Wattage of bulb is which bulb we are using to incident on the solar cell. R is the distance from cell to the area, and what surface area also can be calculated easily. So substitute all the formulas, all the values here, and you calculate the input power. The input power is given, the input power can be calculated here, and fill factor is having the direct formula. By taking the readings from the graph directly we can understand this formula Im into Vm upon Isc into Voc. From that you can understand the fill factor also, and the efficiency. Efficiency is having output power upon input power. Im into Vm upon Pn is the formula to measure the efficiency of the solar cell. From that you can directly calculate the efficiency. So to calculate the series resistance, this is very important. The series resistance can be calculated 1 upon slope, that is I versus delta V, and Rp, that is slope of the graph. V versus delta I gives us the parallel resistance. So series resistance and the parallel resistance can be calculated from the graph, that is I versus delta V and V versus delta I. From the Rs and Rp also can be calculated. These are the results we need, that fill factor of the solar cell and efficiency of the solar cell, also series resistance and the parallel resistance. Before that, as I already told, this theory can has to be understand. Solar cell is a PN junction Solar cell is a PN junction which produces a voltage. As I already told, solar cell works on the principle of solar cell is the application of PN junction diode, which will produces the voltage in the when the visible light falls. When photon incident on that silicon material, the electrons will come out and flow in the circuit. That photon energy is transferred to the electrons, and that electron utilizes to generate the electron hole pair, and also to divide the electron hole pair, and also to travel to the contact areas. These are the three steps followed by the electrons when it gains the energy from the photon. So generally we are using silicon and germanium as the solar cell materials having forbidden band gap of 1.1 electron volts. So these silicon and germanium are the semiconductor materials, can be easily be conduct can get the conductivity. So we are using the silicon and germanium as the semiconductor materials. If the light from the sun or some other visible radiation source is incident upon it, the incident photons having energies greater than 1.1 electron volts move the from valency band to conduction band. This results in the production of excess electrons in the conduction band and excess holes in the valency band. Suppose that the sunlight is incident on the p-type region of the PN junction. The incident light produces the electron hole pairs in the p region. The extra holes produced in p region are insignificant as compared to the large number of holes already present in it. Some electrons immediately combine with holes and get neutralized, while others shift to the junction boundary. So here what we need to understand, in the PN junction region, the whole electron hole pairs will generate when the photons will incident. That electron hole pairs will be separated and will move to the contact materials and will get the electron hole pairs in p region. The extra holes produced in p region are insignificant as compared to the large number of holes already present in it. Some electrons immediately combine with holes and get neutralized, while other shift to the junction boundary. These are all the main steps involved in production of the electricity. When the electricity will produces, here the simple thing we have to do, when the electricity will start generating, we need to change the load connected to it. First we need to reduce the load, slowly reduce the load, and first connect to the maximum load, and after that slowly reduce the load, record the current and voltage readings and draw the graph between the voltage and current. And if you take the voltage and current readings, if you can draw the particular graph that is said to be the VI characteristics, it is also our aim to draw the VI characteristics. When you draw the VI characteristics, understand the open circuit voltage and the short circuit current values. If you know the open circuit voltage and the short circuit current readings, just understand the maximum voltage and the maximum current IM and VM. In the same way, note down the IM, VM, ISC and VOC. From that you can calculate everything, that is fill factor and efficiency. From that we can get the final result, that getting the fill factor and drawing the VI characteristics. That is only our final result. Fill factor is nothing but VM into IM upon VOC into ISC. Then from that we can calculate the fill factor. This is our final result what we are getting. Just connect the circuit and keep the maximum load and reduce the load and get the current and voltage reading successively, and note down the current and voltage readings, how the current and voltage readings are changing in the solar cell, and that is said to be the VI characteristics. So understanding the voltage and current readings, draw the graph and take the VM, IM values from the graph, and understand the fill factor value. From the fill factor also we can get the efficiency values also. Thank you so much. In the next video we will go for the last experiment in our portion.